Welcome back, everyone. If you remember from last time, we were talking about Pythagorean theorem and tangent lines. And I also kind of showed you what a secant was, and we didn't really talk about it much. But if you take a secant, which was essentially this line right here that goes all the way through, if you cut off this part, and if you cut off this part, and only focus on what is in the middle, we call that a chord. And chords are kind of what we're going to be talking about today, but they're also going to mix in with tangents and the Pythagorean theorem. Cool thing about chords is that if you take a line going from the center of the circle and you get it so that it makes a 90-degree angle with your chord, this will be split exactly into half, meaning that if this is 10 meters, this is also 10 meters. If this is 14 centimeters, same thing over here. So that's the cool property about chords that you need to know, because that's what we're going to be basing things off of in this lesson. Fancy math word for that is bisect. Bisect means cut exactly in half. So, in this example right here, because I should have told you, this bisects this chord right here. Or else I should have told you that this was a 90-degree angle, and from there you could figure out on your own, okay, this is 90 degrees or this is bisected. Those two mean essentially the same thing. So if I know this is 90 degrees, well then I also know that this is 90 degrees. Let's think about this triangle first. In the last lesson, we said that all of your angles in a triangle have to add up to 180 degrees. So that means that this 90 plus this 43 plus whatever x is has to give you 180. That looks like a decimal now. So if I want to know what x is, I can subtract out the 43 and subtract out the 90, and that will tell me. When I do that, I get an answer of 47 degrees. So, if this length right here is exactly the same as this length right there, that tells me that this is symmetrical, meaning this 43 degrees is the same thing as this angle right here. So I can then say that y equals 43 degrees. So that's kind of how we use chords that have been bisected down the middle to figure out things that we didn't know. I'm asking you to tell me what CE is in this question. And it looks like, at first glance, okay, maybe I can do something with the radius, because this goes across. Except that it doesn't go through the middle, so we can't actually say this is going to have anything to do with our 26 centimeters there. We're going to have to get a little bit creative with this one. And I'll tell you right now, we need to draw another line on here that is not on here yet. We need to draw that line right there. The reason why is because I know diameter is 26 centimeters. That means this is 13 centimeters, and that is 13 centimeters. But this radius right here is the same as that radius right there. So that's how I can make myself a triangle now that I can work with. So I had to kind of get crafty there and draw my own line in, but that's how we can address questions like these. Now, other thing that I know is that this is bisecting that line. Again, I didn't write that in there. I should have written that in there. But that tells us that that is a 90-degree angle right there. When we see a 90-degree angle, we should be thinking, let's do something with Pythagorean theorem. So I have, this is my 90-degree angle. One leg is going off there. It's 10 centimeters. Let's call that A. So I'm going to put 10 centimeters in for A. Then I have another leg here and I don't know what that one is. Let's call that B. My side across from the right angle, the longest side, that's 13. That is C. Now I can solve for B. So 10 squared is 100. We'll leave the B for now. 13 squared is 169. Do some algebra. I'm going a little faster this time than I did last time because this isn't where I want to focus too much. I want to mostly focus on how we get crafty with these kinds of things so that we can solve questions that don't look like we can actually do them at first glance. So if you go square root of 69, you get 8.31 centimeters. And if I made a multiple choice test where I was hoping that I could trick you into choosing the wrong answer, that would be mean. But this would probably be the first answer. This would probably be option A. The reason why is because a lot of you will forget what that actually means on your diagram. You'll do the math and be like, okay, done with that, next question. You'll forget that that's only half of the total line that we were trying to find. So if this is 8.31 centimeters, and that's the same length as this over here, we need to take this answer and multiply it by 2. So the length of CE is actually going to equal that right there. Okay, what I want you to do now, this question is very similar, except you're going to have to look at it a little bit differently. I think you should be able to do this one. Refer back to what I just did. So pause the video, give this a shot. When you've got your answer, keep watching because I'm going to go through it right now. Okay, so the secret line we have to draw this time is right there. Or if you drew it over here, it'll work out exactly the same because those are both a radius. So that's 16 centimeters, half of our diameter, which was 32. And my right angle is right there. So I have 14 is a leg. The one I don't know is also a leg. And 16 is the hypotenuse. Let's plug those in. Now we get out our calculator. And we do the algebra. Last thing is do your square root. And same thing as before. That is not your final answer. That is only this distance right here. If we want the full distance, we have to multiply by 2. And we can say that AC equals 15.5 centimeters. So hopefully that's what you got. If not, don't stress too much about it. Just make sure that you're good with that kind of question now. And if not, that's what I'm here for.